Hi students, welcome back to our another session of our physical science. Chapter number 1, that is reflection of light at curved surfaces. Part 3 we are going to discuss today. In the last previous sessions we were talking about some prerequisites, how that laws of reflection is going to work, and in the last session, the part 2, we were talking about what are the curved surfaces, where does it they are obtained from, and how many type of curved surfaces are there. If the reflecting surface is inwards, we are going to talk about, we consider it as a concave surface. If the reflecting surface is outwards, we are considering it as convex surface. And along with that, we were discussing about what are the terms associated with that curved surfaces. Okay, that is, we were talking about center of curvature, capital C, pole, capital P, principal axis. Okay, and we were talking about focal point, and we were talking about focal length, and we were discussing about radius of curvature. That are the terms associated with the curved surfaces. That is a small recap of that yesterday's discussion. And today we are going to talk about some important concepts which are so much helpful for our further discussion. Okay. Now, what is the important concept is actually? What is the main important concept? That is, in the last session we were talking about with respect to the plane mirrors. In order to locate the position of the image, two or more reflected rays to get intersect. Wherever the two or more reflected rays get intersected, that location will be the position of the object, position of the image. Now I want to know about what is the position of the image with respect to a curved mirror, okay, or curved surface. To know it, what I need first, I need to trace about what type of reflected rays or how the reflected rays can be produced, or how the reflected rays can be propagated from a curved surface is the first criteria or first condition or first thing that I have to know about. Okay, so we are going to discuss this. It's a very important concept today we are going to talk about. See, already we discussed about yesterday the curved surface. Whenever we are talking about curved surface, we just write in this single two-dimensional view. Okay. Can anyone tell what is it? Fantastic. It's a principal axis. Very good. Okay. And what is this? Pole. Very good. And this is center of curvature. And the exact midpoint of the center of curvature is a pole. Is focal point. Is a focal point. Okay. That is pole, center of curvature, focal point, and the principal axis. And the length between the pole and the focal point we are calling as focal length, and the length between the pole and the center of curvature we are calling as radius of curvature, capital R. Focal length is represented by small f, and the radius of curvature is represented by the capital R. That you have to keep in mind. Okay. And this is the exact mid value of it. Now I am going to take one object. Some object I am going to take some object. I'm going to take some object. From this object, so many incident rays are propagated in all the directions of the objects. So many incident rays are propagated in all the directions of the object. Among that so many, some are directed towards the mirror. Okay, some are directed towards the mirror. Of course, few are not at all concerned about the mirror, not at all coming towards the mirror. That means among all these incident rays which are propagated from the object, we are going to consider some incident some incident rays which are directing towards the mirror. These also so many. These incident rays also we have so many incident rays. So many incident rays we have which are directing towards the mirror. So many incident rays. So many incident rays. So many. So many incident rays we have. Among these so many incident rays, for all these so many incident rays, how can we able to trace the respective reflected ray is our concept today. Okay, how to trace the respective reflected ray. Reflected ray is our agenda of today's topic. Now what I am going to do is just I'll take one example, one or two example. This is not all I cannot make to draw. Now from this object concerned that this is one of the incident ray. This is one of the incident ray which is directed towards the mirror. Now I want to get the reflected ray. I want to get the reflected ray, that respective reflected ray for that incident ray. To trace it, we need a normal. Because the reflected ray should be such that it is going to satisfy the law of reflection. What does it mean? If it is a plane mirror and from the object is incident ray is like this, there should be a normal. What is the based on the angle of it? It is 30 degrees. The same 30 degrees, there should be a reflected ray. So this will be the respective reflected ray of this incident ray. Okay, this will be the respective reflected ray of this incident ray. Fine. Now what I am going to do is, for this incident ray, what will be the respective reflected ray is what is my concern. Okay, so to do this, I want to draw a normal. As it is hitting the surface, I want to draw the normal. Okay, the next step is to drawing a normal. Okay, already I have drawn a normal to the plane surface in the previous example. So drawing a normal have two conditions. Drawing a normals have two conditions. I will be discussing about the prerequisites concept in the first topic. First video we were talking about how to draw a normal. That is, drawing a normal has two conditions. That is, okay, it should be perpendicular. It should be perpendicular to the surface, as well as it should be at point of incidence. It should be at point of incidence. Two conditions to draw the normal. Normal should be perpendicular to the surface and it should be at the point of incidence. These are the two conditions which are going to be satisfied. They should be satisfied. Okay, suppose I am drawing, this is a point of incidence. Okay, that we know that here we have to draw the normal. Now, which one should be perpendicular? Which line? Will this is a perpendicular line? Is this is a perpendicular line? Or is this is a perpendicular line? Or is this is a perpendicular line? Or is this is a perpendicular line? What will be the perpendicular line such that perpendicular line to the curved surface at this point, so that I can able to consider it as a normal. What exactly, which line is the exact perpendicular line to this curved surface is my criteria. Understood? Among this all, how can I know about which line is the perpendicular line? Perpendicular is exactly 90 degrees by that curved surface. How to trace it? Okay, for example, if it is a parallel line, if I draw a line which is exactly vertically perpendicular, then with the 90 degrees, that would have acting like a perpendicular. This line is perpendicular to this one. This line will be perpendicular to this one. That I can draw if it is a plane surface. plain line, plain surface. Now, as it is a curved surface, how can I able to identify which is going to be a normal? How can I draw a perpendicular line to that curved surface? So, to draw it, I am going to use a basic geometry from the mathematics. Basic geometry I am going to talk about. That is, first what I am doing is I am going to draw a tangent. Okay, I am going to draw a tangent at this point. Tangent is nothing but a straight line which is drawn to a curved surface which is passing through only one point of that curved surface. Okay, now what I am going to do, I am going to draw a tangent. This is the tangent. I am going to draw a tangent for this. Okay, for example, assume my hand is a curved surface. If I draw a line to this where it is intersecting at only one point, at one point of the intersection, only one point at this intersection. Okay, this is a tangent to this curved surface. Tangent to the curved surface. This is a curved surface. This is a tangent. Okay, straight line. It is tangent. Now this is a tangent I am drawing. Now, if I draw a perpendicular to the tangent at this point. Okay, if I draw a perpendicular, concentrate here, very important. If I draw a perpendicular to this line at this point, it obviously acts as perpendicular to the curved surface. Is it okay? If I draw a perpendicular to the tangent at the point of incident, it indirectly is going to act as perpendicular to the surface. Fine, okay. So, what I am going to do, I am going to draw a tangent to this, I am going to draw a perpendicular to the tangent. See, I am not using scale and all here. Just, okay, I am drawing a perpendicular to the tangent. I am drawing a perpendicular to the tangent. A perpendicular down to the tangent is going to act as perpendicular to the surface. Now what happens? This line, whatever it is drawn, will acting like a normal to this curved surface now. Acting like a normal to the curved surface. So what I am going to do is with respect to this angle of incidence, that is 15 degrees for example, the same 15 degrees I am going to draw a line which is going to the reflected ray for this incident ray. Is it fine all of you how to draw the normal and how to draw the respective reflected ray to a given incident ray? Have you understood? Simple concept. The concept is that, today's concept is that drawing normal to curved surface and respective reflected ray for a given incident ray. Is it okay? Directly perpendicular line to the curved surface, as we cannot able to draw a direct perpendicular line to a curved surface. First of all, we are going to draw a tangent to a straight line to that, as a tangent to that curved surface at that point of incident, and a perpendicular line drawn to the tangent is acting like a perpendicular to the curved surface. Is it fine? Perpendicular drawn to the tangent is acting like a perpendicular to the curved surface, where that perpendicular line which is considered perpendicular to the curved surface, it is going to act as normal. With the angle of incident and the angle of reflection, we are going to, based on the law of reflection, angle of incident is equal to angle of reflection. We are going to draw, we are going to concern about respective, we are going to trace the respective reflected ray. Is it good? I hope you understood this. Suppose one more if I draw one more. Keep in mind here, the same thing I'm just making. So this is the incident ray, this is normal, and this is the reflected ray. One more I'm drawing, suppose, for example, I'm drawing one more, such this is the incident ray. This is the incident ray. For this incident ray, again I have to draw the I have to trace the respective reflected ray, and I have to draw the to trace the respective reflected ray. I have to draw the normal. To draw the normal, drawing a perpendicular at the point of incidence for a curved surface is not easy job. So I am going to use the help of the tangent from the basic geometry, from the mathematics. I am going to draw a tangent to this. So a perpendicular line drawn to this tangent. A perpendicular line drawn to the tangent. Perpendicular line drawn to the tangent is acting like a normal based on angle of incident 10 degrees, for example. The same angle of reflection 10 degrees. The same angle of reflection 10 degrees. We are going to get the reflected ray. For this incident ray, this is acting like a normal, and this is a reflected ray. So here one thing that we are propagating with, we are behind with is to know the respective reflected ray for a given incident ray. There is a need of drawing a normal. And as it is difficult for drawing a normal to the curved surface, we are going to take the help of a tangent, and the perpendicular drawn to the tangent is considered the perpendicular to the curved surface, and it is considered as normal. And based on the angle of incident with the same angle of reflection due to the loss of reflection, we are going to trace the reflected ray. That's it, simple concept. Okay, now we have a problem here. Not a problem, we have a time killing process here. For every incident ray, to get the reflected ray, to get its respective reflected ray, drawing a tangent and drawing a perpendicular to the tangent, and considering that perpendicular drawn to the tangent as perpendicular to the curved surface and treating it as a normal, and measuring the angle of incident, measuring the angle of reflection, and drawing the respective reflected. It is a time-taking process. So to minimize this, all drawing the tangent and considering it as perpendicular to the line drawn perpendicular to the tangent as the perpendicular to the curved surface, we are going to observe one thing here. From this figure, we are going to observe one thing, that is from any point of incidence. Keep in mind, from any point of incidence, if you draw a normal to the curved surface, it is passing through the center of curvature. Okay, the tangent from the tangent, like perpendicular line drawn to the curved surface of the tangent is passing through the center of curvature. The perpendicular line drawn to the tangent and treating it as perpendicular to the surface, it is passing through the center of curvature. Any perpendicular line drawn to the curved surface, we notice that it is passing through the center of curvature. So, based on this conclusion or based on this observation, we can skip a step of drawing the tangent now. What does it mean? For example, I am taking this as this ray as incident ray. I am taking this particular ray as incident ray. This is the incident ray. Now, as per the previous discussion, to trace a normal, I have to draw the tangent to the curved surface, and the perpendicular line drawn to the tangent is acting like a perpendicular to the curved surface, and it is treating as normal. Now, obviously, I am skipping the step of drawing the tangent because from this point of incidence, I observed that from the point of incidence, if I draw a line which is passing to the center of curvature, from the point of incidence, if I draw a line which is passing through the center of curvature, obviously it will be perpendicular to the curved surface and it is acting like a normal. So by skipping this tangent, what I am doing is I am going to draw a line directly such that without drawing this tangent and all, I am skipping the step of drawing the tangent, and if I draw a line directly from the point of incident which is passing through the center of curvature, obviously it is acting like a normal. It is acting like a normal, and based on the angle of incident, I am going to get the respective angle of reflection so that I can able to trace the respect to incident ray for this given incident ray. Is it okay, all of you? As we have infinite number of, or so many incident rays, every time to trace the respective reflected ray for a given incident ray, every time drawing a tangent and treating it as drawing a perpendicular line to the tangent and treating it as a perpendicular to the curved surface and considering it as normal, as it is time taking process, we just minimize our step. We just minimize our step by observation that if we draw a line from the point of incident such that it is passing through the center of curvature, by the observation of a perpendicular line drawn to the curved surface as it is passing through the center of curvature, we came to a conclusion that without drawing the tangent, if we draw any line from the point of incident such that it is passing through the center of curvature, will be perpendicular to the curved surface and can be considered as normal, and based on the angle of incident we are going to get the respective angle of reflection such that we can able to trace the respective reflected ray for a given angle of for a given incident. Okay, this is the main concept, key concept, that is to draw the normal to the curved surface and to draw the respective reflected ray. I hope you understood this. Now, what is my concern is, see here, already we discussed in the last session to draw or to trace the location of the image of an object. It is enough if at least two reflected rays get intersected. At least two incident rays get intersected. That position of the intersection of the two reflected rays, at least two reflected rays, will be the position of the image. Okay, that is what we discussed in the last session. So what I am doing is, as I have infinite number of so many incident rays, where I am going to take the consideration of all these so many rays, instead of taking all so many rays, I am going with the four special type of incident rays. Already we discussed one. Here incident ray, and drawing the normal and all. So we have skipped drawing the tangent. Now I want to skip drawing the. We skipped drawing the tangent to draw the normal. Now I want to skip drawing the normal to trace the incident ray. How can I do that? Okay, I want to skip the drawing of the normal to trace the incident ray. I want to make it. Okay, to do that, I am going to use four special type of incident rays. Among so many incident rays, I am going to use. Okay, or we will consider only four special incident rays which helps in tracing the location of image of an object. Okay, now how do I do that? That is going to talk about what are the four special type of rays. First we will discuss about that. What are the four special type of rays that we will discuss. Then afterwards we will go in with how they can be. Okay, so among so many incident rays, I am going to take only four special type of incident rays which are able to help the location of the position of the object. Okay, among that, the first type is incident ray is parallel to principal axis. The ray what I am considering among all incident rays which are propagated towards the mirror, from all incident rays which are propagated towards the mirror, I am going to take only four special type of rays. Under that, the first one is incident ray is parallel to principal axis. So the incident ray is parallel to principal axis. Now what will happen? The second one, the incident ray is passing through focal point. Incident ray is passing through focal point. Third one, I am going to talk about incident ray is passing through center of curvature. Incident ray is passing through the center of curvature. And fourth one, incident ray hitting at the pole. So incident ray among infinite number of so many incident rays which are propagated towards the mirror, I am going to take four special type of rays such that I want to minimize the time by skipping the concept of drawing the normal. In the last case, we have skipped drawing the tangent to draw the normal, to trace the respective reflected ray. Here, what I want to make it without drawing the normal. Is there any way I can trace the respective reflected ray? Is what is my main concern. To make it possible, I am going to study about four special type of rays which are propagated towards the mirror. Among so many incident rays, I am going to consider four special type of rays which help us to minimize the time, to utilize our time flexibly. That is, among that, it is one incident ray is parallel to principal axis. It is incident ray is parallel. Incident ray is parallel to principal axis, and incident ray is passing through the focal. This is one ray. It is incident ray is passing through the focal. Okay, and one incident ray is passing through the center of curvature. The another one, incident ray is hitting at the pole. Incident ray is parallel to principal axis. The first one, incident ray is passing through the focal. The second one, the incident ray is passing through the center of curvature. Third one, an incident ray is hitting at the pole. That is the fourth one. These are the four special type of incident rays that we are going to take into the consideration to get the respective reflected rays without drawing a normal, to minimize our time. See, there are only two rays are important for us to locate the position of the image. Actually, the agenda is to know the intersection of at least two reflected rays. Okay, see, among these four, depending on the time or depending on the situation, any two I will utilize. Any two incident rays and the respective reflected rays I will utilize to locate the image position. Okay, for that purpose and to make our time flexible and compact, I'm using this fourth special type of rays among all incident rays. Now the tomorrow session will discuss about for this incident rays parallel to principal axis without drawing the normal, how can I get the respective reflected ray? For this one, how can I get the respective reflected ray? For this one, how can I get the respective reflected ray? For this one, how can I get the respective reflected ray? That we will discuss tomorrow, and we'll see some image formation, some concepts. I hope you understood this session. Thank you all of you. Keep smiling and have a good day. Take care. Bye bye.